All right, we have recording on. So the first thing to do is the EG. So why don't you open EG? The best way to do that is if you have already created shortcuts, then that's the best way. But to find it in a list of programs, it's a pain. So the best way is to use the Windows search function. Just to start the search window and start typing SAS Enterprise Guide, and it will appear somewhere here. So there's only one Enterprise Guide option to choose. And I already opened it, so I don't have to click that, but make sure you open that. It's going to be, you'll have a window that prompts you to open or create a new project. So simply ignore that. You can kill that window, or you can say, create a new project. Let's see. So, and the thing I'm demoing is similar to this, but not exactly. I'll use the data set that I posted on the Blackboard. So it's not going to be the same data set, but the steps are similar. From here, remember the task is to convert mpg.csv file into SAS file format. So you can go to import data. That's the first thing to do. That allows you to import a variety of formats and convert it into SAS. And then go ahead and then find the CSV file. And the first page is basically the directory information, file type, any metadata. So we'll go directly to the second step. Everybody's following? Fine, right? So here, there will be a little bit difference between what I'm going to demo and what's printed on the PDF. So this step gives you an option to configure, where would the loading of the real data start in that text file, in that CSV file. It's basically a text file. So depending on how the text file is structured, there may be miscellaneous information in the top, which you don't necessarily load into the data. Like the case is similar to what is printed on the PDF. There is publisher's information. There is some other information. There's a line of dashes. Hey, and then following is the header of the columns. Then these information, the row of data such as manufacturer, model, that's displacement, year, and such, these are the header of the variables, right? So they will designate the name of a particular column, and that is where the data will start. Anything other than that before this line, you can specify the program to ignore it. So that is what it does on the tutorial, on the PDF tutorial. The data starts from the fifth line, and the file includes headers on the fourth row. But here we have the headers on the first row. We have the data starting from the second row. So that is that's the default values. It's not always work, but most likely it works. A CSV data file is typically structured like that. And there is one thing very critical that you should do, which is not default setting. I think SAS should make it default, but it just creates a lot of problems, which is easy fix. But so make sure you click this box, always, every time, always. What it does is it will convert the names of the columns to be compatible with SAS format. So a problem that would emerge if you don't tick this box is that you have a variable that has a very long name, and SAS won't take it, give you an error, which is hard to debug. So every time, remember, do that. You can check a few lines of the data set, which is pretty intuitive. So the next stage is sort of a SAS report of how these variables will be in terms of the name, label, and the type of data, and the in format, sort of how the information on that variable will be recorded. That's a little bit more technical. SAS pretty much figured everything out, and there's rarely any need to change these, unless you are in a very advanced level and you need to customize some of the efficiency aspects of the data set. At this level, you don't need to worry, but make sure that you see what you're expecting. If you know the data set well, there are certain columns that are critical, and you want to, at this step, you want to check that those variables are in it at least before you proceed further. And you also have the option to untick some of the boxes to not include that variable if you don't want it. Sometimes the data set can be very large, and you don't necessarily put in every column, right? But removing the columns in CSV file is a pain, because it's text file. You have to remove it from every row. It's not as convenient. So SAS provides a very easy solution for that. So for example, some of the columns here, we have manufacturer, which is going to be, so this is a car automobile data set. It's a data set of about 200 rows of a model, make and model vehicle that records the fuel efficiency of that vehicle. It has city and highway fuel efficiencies. It also has the other characteristics, the mechanical characteristics of the car, like number of cylinders, type of transmissions, what type of drivetrain is it, and the class. I guess class is, I don't know, luxury or economy, something like that. But manufacturer is going to be textual. It's going to record things like Ford, right? BMW, those information. Anyway, so let me go to the next stage. And typically we don't change the default settings here, I think. So, and when you finish, you have a SAS data set open automatically for you. This is just for you to browse it and to make sure things are as expected. Quickly, you can quickly review it, or you can close it. Bless you. So this SAS data set is in the memory. You need to export it to save it, to be able to use it in EM, right? But if you don't need to use it in EM, you can keep it here. You can do analysis on it. In fact, we'll do some analysis on another data set here a little bit later when we work on the EM. So I'll demonstrate some of the statistical analysis you can do quickly in EG. To save it, you do need to save it, right, for EM. So there are a couple of ways to do that. Either when it's open, you can say, let's see. When it's open, I think there's a option, export. So export, I think typically the first option. And here's the second point I want to make. Always change the name of the data set. Don't leave it default because you won't be able to find it. It's a pet peeve of SAS. You know, they are so good at statistics, they're not good at intuitions. Anyway, so always, change rename the data set, make it easier to remember, easier to find. So I'm just gonna do MPG here, and go ahead and save. If you turn on the extension, display extension feature in Windows, then you'll see this long file extension at the end of the file. I'm not gonna save it. I already have a version of MPG here, so I'm gonna skip this step, but go ahead and save it because you'll use it later. Feel free to close this. It won't delete the data set in the memory. It simply close the view. All right. So that finishes the EG part. At the back of this PDF tutorial for EG, there are some steps illustrating how to do the basic tasks in EM, like creating a project, creating a library, creating a data source, and creating a diagram. So this is an old version of a tutorial. Later I had better versions, so we'll use the other better versions for the EM, but those are just some information in case you wonder. Right. How do you feel about the software? Good. Is it hard to use? I mean, have you used something similar? Or does it feel like something similar to what you have used, other statistical software?
Exporting the data, the steps are similar, but the way you do it is not similar. It's similar.
Mm-hmm. Like what? Other
Jupyter notebooks too. So we use
that's programming. That's very different. That's kind of the other end of the software application, and this is not the most user friendly, but it's the click and drag. Yeah. You may find it's very similar to IBM. There's a modeler, IBM modeler, which is sort of a very similar version of a data mining tool platform by IBM. It's also quite similar to SPSS if you have used it. Yeah. Okay, so far so good. Any questions? No? How many, raise your hand, I'm just getting a sense. Raise your hand if you have tried to create a project in EM. So most of you find that successful or have different questions?
Just couldn't find the table because I didn't rename the thing, but now
now you got it. Yeah. What kind of problem have you experienced in using EM? Or what is it about the software that doesn't feel that good or not as easy to use? Some of the troubles I can sort of point out early on. No? Well, let's just get right into it. Okay, so I've opened my EM. One thing to make sure you do is you open the workstation version, not the client, because you already installed the workstation version. So I've already opened it, but the way you do that is similar. You go SAS Enterprise. Minor workstation, make sure you open that workstation. So this is the, let me open a sample project for you, just to get a taste of the interface. Okay, let's see. Okay, so that's the main interface. All right, let me stand here. So as any other software, you have the file, the menu buttons and drop-down menus under each, and these always stay the same. And you have a bunch of shortcut toolbar of shortcuts. That is somewhat routine tasks that you would do, but actually you rarely do it. I don't know why they are there. And below that you have a this is the project view or project panel. So all the project files or project objects are here. Three main things. You have the data sources. You have diagrams, or that includes the basic work area of your process models for data mining projects. And also you have other model packages, which are imported tools. For now, we're using the other two mostly. Below that, you have a property panel, properties, characteristics of different objects. And because there are different kinds of objects here, there are data sources, and there are diagrams, and within the diagram you have processes. And two basic elements of a process is the nodes and the sequence. So there are various objects here. Every kind of object has its own property, and every model has different sets of properties. So this area is going to change, conditional on what kind of object you're working on. So it's kind of like a contextual menu here. But you'll notice now it's very short. It doesn't have many options to change. But later on you will see more options. This part is more of a help tool. It provides miscellaneous information about some. If you click that, it'll explain what this role says, and provides pointers to additional resources. Okay, so I'll open this diagram. A typical diagram is a vast white area. It's like a canvas. You put stuff on it and make a process. The two basic elements here, you have nodes, is the boxes of things, but they are actually of different type of nodes. You have data node, you have some exploratory tools, and some modeling tools, evaluation tools, and other data related tools. We'll get into the details. You'll see that here all of the nodes have a green tick mark. That means this node has been run, and you can extract results from these nodes if you want. If you make any change to these nodes, then that green tick circle will go away, indicating that you need to run again before you can trust the results. And there are buttons, there are menus right above the this is the diagram panel, right, like the canvas, and each of these buttons will bring up more buttons. These typically don't change. There are many options here, but mostly what these does is to make it easier for you to create exactly the type of node you want. All these tools, majority of these tools are to create a specific type of node. So under the model tab, you have a dozen of different models to create. Every button create a type of model. Some of them may be similar to each other, but some of the others are different. And it even have some text mining applications here, time series, more advanced analysis. So a basic explanation about the interface. And I'm going to start to mess up with the nodes. When you click a node, the contextual menu for the properties changes. It changes very dramatically sometimes. It does have the basic sections similarly. It has a general section, it has a train, because all of these are kind of model-based nodes. So they have the train section, but under the train section, what kind of properties you can modify with that model depends on what the model is. Okay, a little bit about working with the processes. After you drag and link, you can move things around. You can link two nodes by dragging from one end to the other end, and then when you move the other one, it will stay. I know that some of your laptops are very high definitional, and the nodes look like these. So if you face this situation, then simply enlarge it. Don't make it too hard on yourself. But if your menu items are too small, like you have a high definitional, screen, video card, and your daily resolution will show very small menu items, then you would have to change the resolution. That is what I found out to be the most effective way. If you try to mess up with the font size, it gets funny. Sometimes the line breaks without making it very comfortable to look. So that's what I find out to be the best way. But talk to me if you have that problem. So you can zoom out, you can zoom in, and you can also arrange it in a way that's neat. So there are some options here. You can use the auto arrange feature to put them on the horizontal line, sort of make it prettier. You can change that. It won't be exactly what you want, just because there are many things going on here. But based on that, you can tweak slightly to make the way you want, right? So I find that to be, and you can also make it vertical, like from top to down. It's like a waterfall, All right, so it's just your style. Choose whatever you like. So that's a quick walkthrough of the interface. And we're going to do specific projects. Any questions so far? Right, close the project like this. Be careful not to, even in a rush, don't click this, because it just goes away, it disappears. It just completely goes away. But it will remind you, but in a rush you'll say yes. You're thinking that you're closing it, but it's deleting, it's shredding, and it's gone. I had a team is approaching the end of the project, and one of the team member had the project lost like that. That's painful. So be careful. Saving. Okay. All right. So good. We're good. So I'm gonna do this, right? A lot of the first few chapters here are informational. They're informative. They explain what I just demonstrated. You can look at them, in detail later. The beginning of the project here, the sample project, starts from chapter 3. So I'm just go right into chapter 3, page 9. So follow me and make sure you have a partner. Bronwyn, do you have your SAS ready?
I'm going to bring my laptop today.
Come sit over here.
Yeah, if that works.
Should I get a version or no? Yeah, I don't know how to. I thought you had a different project. She had a project.
You're gonna have to drag a chair.
I think it will be probably easier if you know, there's not much space here. If you work with Shu, it might be better. Make sure you have a partner. How do I? You have that. Not yet. Okay. Yeah, so that's fine. We'll go from the beginning here. Oh, you don't? Yeah. So let's make it work. So hopefully interview.
This one,
So I think you can sit by the room. We'll make some space here.
Yeah.
Jerry doesn't have the software ready, so we need a chair. All right. Make sure you download the SAS data file. It's a donor raw, right? It's not donor raw. From this week's folder. Right. So prepare the data set and I'll wait for you for a couple of minutes. Make sure you have them ready. We'll start right away.
the MPG.
The other,
Oh.
the data set from this week folder, week 2.
It's already in
Professor, you want us to have it loaded in the directory folder, and we can just import it?
Yes, if you already done the library part.
Yeah. Okay.
Good. Okay, Alejandro. Need more time with the data set? Good? Everybody? Good?
We
Okay.
don't have to go through enterprise again, right? Because it's already a SAS table.
You mean enterprise guide?
Yes.
No. Yeah, it's already SAS table, so we'll work with SAS EM. Okay, we're gonna start. So we're gonna start from basically from page 9. But I'm gonna be pretty fast. I'm not gonna explain exactly every piece of information, but I'll highlight the important ones. But anytime if you have questions, stop me, let me know. So open your SAS EM. We'll open the first project here. So name for here it's a donation, so I'm gonna use a slightly shorter name. I don't like long names. I'll use charitable or charity as a project name. I'll put it in an EM folder that I typically keep everything related to EM in the directory. So it's like that. And you'll see some summary information about the project, and then the project is created. Very simple. Now the next step typically is to load in the data set. But for any new project, you will need to create something that's called library, which is a shortcut to a directory. So, and library is not a sort of an explicit entity here. So you will have to go to File and New and create a library. So you can use any name. It's as long as it's 7 characters or shorter. And point the path to the folder that you keep the EM resources. And it's a summary page. And just click finish. Any questions? No? Everything's good? Great. So that's preparation steps. Now you can create the data source. You can either right click or use the same new file new. Same result. So you want SAS table, that's the only option. Try to find it. You'll see a list of it's a kind of a different directory structure, but you'll find the library that you just created and look for the data set we're going to use. It's donor raw data. Yeah. And some miscellaneous information. You'll notice that there are close to 20,000 observations, which means rows, number of rows. So for the Excel, from the Excel standpoint, it's a large table. From SAS standpoint, it's not large at all. It's a piece of cake for SAS, but and there are 50 columns, 50 variables. Here, let's see, are we doing something here? I don't think so. Oh yeah, well, let's see. No, we're not doing anything here. This is to teach SAS how to be smarter in guessing what you want. But for now, we can skip that. I don't think it's in the steps as well, yeah. And the next step, this is pretty important. So this is to specify some meta information about the columns here for the sake of modeling and data mining purposes. So this is getting a little deeper into the EM context for better modeling and using these data sources. As you would expect, the gray areas are a list of variables. There are 50 of them, right? And immediately following that, so this is not the table itself, right? It's a metadata view of the columns. A critical piece of information is the role of the column. Typically, for most of the models that we will use, all of the supervised learning algorithms, including decision trees, regression, neural networks, they are only one target variable, which is one of the role here. If you look at the drop-down menu, there is a list of different roles here. Two kinds of roles are necessary for most of the models we learn. There are exceptions later on for other kinds of models. For now, you'll be used to this convention. We'll have one and only one target. So one of these variables has to be target, and only one variable can be target. Most of the other variables will be input. So that's why you see most of them input here. But toward the end, you see two target, right? So one task that we have to do is to decide which target to retain and what to do with the other one. So here, you are going to retain the target B. So without changing anything about target B, but for target D, we're going to reject the variable And the reason SAS put target as the role for these two variables, can you guess? Yeah, the name, because the name has target in it. So SAS guess. You know, it's pretty smart, but you can see the limit. You know, we typically wanted only one target, not two. But anyway, so give you a little bit background here. This is a data set about donation campaign. So imagine a marketing company is sort of soliciting donation from a pool of potential targets, right? So they have their phone number or mailing address, other demographic information, neighborhood information, maybe credit scores, maybe profession, marital status, everything that's easier to collect or buy, and then they can sort of make a model of predicting who are those that are more likely to donate than the others. So then they can target differently. And this data set records the results from previous campaigns as well. So this is one of the campaign here, and two targets here record two pieces of the critical information about the outcome. Target B is a binary variable. This is the term we use. Binary is there are only two different values with this numeric variable. It's 1 or 0, yes or no, meaning it's a dummy kind of variable. It records whether or not this person, this potential customer, donated or did not donate during the last campaign. So it kind of tells the machine some information about the outcome. What happened to this customer, given his or her other information like age, credit score and things like that, income, so that machines can infer by trying to find patterns, links between those other variables and with the target. So you can kind of imagine an algorithm that links those other information with this critical outcome information to the point that maybe, given enough accuracy, then the algorithm can predict more accurately about a future customer given these information, so that business can make decisions more informed rather than guessing or hoping everything works, right? The companies can, based on the recommendation from the model results, the company can avoid targeting a segment of the customers because the predicted response is very low. So a little piece of information. We're going to use that binary variable as a target, but the other variable is the amount of donation that was made during that campaign, if that person donated. So can you imagine the two variables? Let's see. So the two columns, one is a binary indicating whether the customer donated or not. The other records the amount of donation of that person. Do you see any problem? Or can you think of any? So what will be the values of the two columns?
So if it's a yes, then we'll see a value. If it's a no, there'll be no. Yeah.
It'll be empty.
Blank,
Yeah, because we don't know. And this piece of information is unavailable. Yeah. So this is relevant to the missing value case, and we're going to talk about later. Right. Right. Keep that in mind. And all the information I said is in the appendix portion about this specific data set. You can find it on page 60, something like that, or 50, 58. Okay, so we did that. for the rest of the variables, we'll keep them as is. Right. Okay. This is a long list of variables. We'll take a look at what the information we have. We have homeowner. Whether or not this person owns a home or renting or other status, age, gender, and lifetime gift amount. Like cumulatively, how many in total this person has given. And SES, even socioeconomic status. Different tiers, different categories. Yeah, so quite a few variables here. So we can go to the next step. Let's see. Do you wish to create a sample? We're going to use the entire sample here, so we'll say, well, default is no. We'll go to the next step. This is still fine. Make sure, but the default is raw. Choose the raw, because we will make partitions from this data set to be training and validation. So using the raw will be the most inclusive one. You have a summary list of types of variables here. So here, a little bit of other background. What is interval variable to you, from your understanding? It is a number, yes. There may be different kind of numerical variables, interval being one of them. What do you mean a range? There's a range. But what are the other kinds that you can think of? It's also numeric. Decimal. Let's see. Does nominal make sense to you? What is nominal?
So a name could be something with like letters.
Yeah, something like that. So nominal, sometimes referred to as categorical. It has a limited number of unique values in it. Like for example, gender. Let's see, gender has only 2, maximum 3 categories we typically use, right? And something other, education background. Primary, elementary, middle, high, 6 or 7 levels. For these, we call them nominal or categorical sometimes, but sometimes they are recorded as numbers as well. But indeed, they are referring to some categories, not the numbers exactly. They don't make exact meaning, right? If we code female as 1, male as 0, the numbers don't. It's not meaningful per se, without the meaning behind it. So that's nominal, but interval are that those values are meaningful values, and the range can be infinite. It's continuous, and it's typically decimal as well. So the decimal values can make sense. 0.5 means half of 1. So in that case, that's continuous. We sometimes call it continuous variable, interval variable, or simply numeric variable to refer to this kind of variable by default. So we have, and a special case of a nominal or categorical variable is a dummy variable. Dummy variable is a binary variable. It's same meaning. A variable that has only 2 possible values, right? High or low, large or small.
Would temperature be interval? Like the temperature?
Temperature. Very interesting. we typically treat it as interval. Yeah. Yeah. Although it's not as exactly the same as age. I mean, in terms of the intervals between the values, 80° and 81°, the difference is 1 degree. But this 1 degree, is this 1 degree of difference the same as 60 to 61? May not be the same, because it comes down to feeling. But age of 1 is always true. Age difference of 1 is 1 year, and the time is defined. But temperature is not, it's a little fuzzy there. But for the analysis purposes, we treat them the same. Yeah. Great. So I think I skipped some step about the decisions somehow. Let's see. So I think somewhere in the middle, I click next, but probably shouldn't have. But we can get back to the steps there. So we want to customize the decisions and the probabilities here. And the reason is I'll talk about later. Come on. Take some time. Maybe in the back. Yep. No class targets. That's interesting. So sometimes you'll face a problem like that, but try to debug. It has to be something about a target. So target B should be binary. Here I left it as interval. I shouldn't have. It should be binary. It makes a material difference to the models. For models of classifications, like try to predict a donor or not. That's a classification problem. It requires the target to be categorical, so it cannot be interval. It's actually binary here, so we'll do that, and hopefully we can do the decisions here. Right. So we'll build, according to the tutorial, we'll build some parameters about the decision criterias. So think about the context again. It's making donations, right? And the purpose of the model is for the machine trying to learn what kinds of characteristics about these customers help predict whether or not this person is going to be a donor or not, right? So it leverages the relation, the correlations, the covariances, and the structure of the covariances between those input variables and the target, right? And then companies decide to elect one decision based on one outcome. If they predict this customer to be likely a donor, then they should make the decision, or likely to be sending out a solicitation, or make a phone call, or maybe send a mail, poster card to ask for donation. And that is that costs money. In the ideal world, you can send it to everybody, but that's not realistic. You have to think about the cost. For somebody who you don't predict as a high likely donor, then you'd rather skip that person, but and focus on the segment that has higher likelihood of donation. So that is the case here. So let's follow the tutorial. We'll build the criterias for the decision model. One thing to change here is the prior probabilities, and the reason is like in the data set, you know, a summary statistic of that target, that's target B, is that 25% of the sample has a value of 1. So that means 25% of the sample made a donation during the last campaign. 75% of the sample didn't, has a value of 0, right? Now, if that's the case in real life, that would be fantastic. But realistically, it's not typical. So do you know typically what is the percentage of people donating money in any context?
Only less than 25.
That's a smart guess. Yes, it has to be. You know, I kind of hinted. But what is the level that you can guess or know of?
10%.
10%. From Dennis?
Yeah.
It's a good guess. But not quite yet. Another try?
3%?
3%. Quite close.
Oh, yeah?
Yeah. 4 to 5. You know, 3, 4, 5, something like that. So very, you know, but that's reality. And you kind of, you know, it's rational. Right, that makes sense, right? So that's a problem that the data analyst has to face. So let's see, if you try to collect a data set, you have a kind of a large sample size, you know, 20,000 like this one. If only 5% of the sample make donations, how many observations do you have about donors? You make the math. 20,000 times 3%, 600. Yeah. So you only have 600 cases of donors, where you have the majority of them non-donors. So this data set is, you know, is highly skewed toward non-donors, and tend to not have enough observation to learn for the machine about donors. So that is a problem. If you train the algorithm using that kind of a data set, it's going to give you a large, I mean, it doesn't have enough to learn about, you know, about the donors. So in these problems, you face kind of a, you know, under-sample problem of the donor. But this is not only in donation case, it's only in other business or other non-business situations. Can you think of one? Like, you know, a phenomenon that is worth predicting, but the chance that one of the values, let's think about binary situation for now, right? Because there are only 2 outcomes possible for one phenomenon. One side has very low representation, it's low percentage, the other is the majority cases. Can you think of one case? Elections, in which sense, like the candidate, the winner?
Yeah, there's gonna be, we're usually there's gonna be either or.
Okay, so you mean a bi-party
Yeah.
election case? Can you, so in this context, can you think of one metric that you're trying to predict?
How many votes they receive?
How many votes each side receives? It is a binary choice for any ballet, right? But it is a little bit. It's not the kind of a predictive problem we try to say. Think from the presidential candidate point of view. Let's see, for a geographic region, the party is trying to estimate the number of votes versus the other side, or percentage of votes that the candidate can secure. It's not quite yet the kind of problem. Okay, let me give you an example. Predicting serious disease like cancer. Okay, it's a yes or no. The majority of the cases, it's no. Majority of the cases, and hopefully, right? But in some cases, it's yes. If you construct a data set, then it's only going to be 1% or maybe 3%, or a low percentage of cancer cases versus healthy cases, and positive versus negative, and it's going to lead to the same problem. Another technology-related case is cybersecurity cases. Cyber attacks. If you observe the sort of the visitors of the website, then it's going to be very low percentage that they are hackers. But for the machine, the objective of the tech team is trying to predict which visitor is a hacker, right? So they face a similar problem. A very low representation of the positive case that they try to predict. That's the kind of problem here. So the technique to deal with that is to do selective sampling. Selective undersampling and oversampling of the different cases. For cases like this, you want to oversample the positive cases and undersample the negative cases so that there's a good mix of and a good representation of both cases so that the machine can learn and increase the accuracy of the model. And that's why the sample has higher percentage of donors, even though in reality is not. But for the model to properly construct the final solution, we have to tell it that in general, what is the percentage that we expect the positive case to be? Not like how it's represented in the sample, but in reality. That's why we need to tell it the prior probability of these two situations in reality. So here's what we do. We need to change it. Do you want to enter? So adjusted prior probabilities. We'll put 0.5% here and 95% on the other side. Yeah, and not hit OK quite yet. We'll have to customize the decisions as well. Okay, now, so here is the decisions that the businesses can choose to do. And if you're the business, let's say one objective can be that you want to predict whether or not a person is donor or non-donor to the highest level of accuracy as possible, right? You want to increase the accuracy performance of the model. That's fair, great. But think of a case where you have 5% donors and 95% non-donors. Maybe a smart strategy to do in terms of technically predicting it right, maybe to predict everybody as non-donors. That's easy. Then you have 5% error rate and 95% accuracy rate, right? If you predict everybody to be non-donors, you are correct 95% time. But does it solve the problem? It's not realistic. It's a smart strategy to boost the performance, but it doesn't solve the problem, right? So instead of prioritizing the prediction accuracy, you can prioritize the expected profit based on the decisions that the business do according to the predictions. So here is the step that you do to intervene with that sort of the more conventional precision-oriented strategy to profit-oriented strategy. You attach different cost structure to different decisions so that the algorithm is will try to maximize the profit by making predictions. So then you get better return instead of simply being right, right? So let's take a closer look at the decision profit here. Let's say there are only two outcomes here, right? a person is either a donor or a non-donor. And the result will be that if the person is donor and you happen to send a solicit to the person, then you will get a big return, right? But if the person is non-donor, even if you send something, he or she is not going to donate. And whenever you send a solicitation by mail, let's say this is the conventional setting, this is mailing the solicit to the potential donors. So every mail is going to cost 50 cents. That makes sense. That's postage, right? And paper production cost. But every time you get a donation, you'll get a big fat check. So here we need to put in those numbers. What do we expect the business to lose or earn based on the outcome of the decisions of the donors? So here, let's change it, and I'll explain what does it say. Let's see. I think decision weights. That's the decision weights, and here is for you to customize the labels for different decisions. We'll keep it as default. So here, the level means the target B. So does target B equal to 1 or 0? It equals 1 when the person donates money, or equals 0 when the person doesn't donate. Decision 1 and 2 means decision 1 is when the business sends a solicit mail. Decision 2 is when the business ignore the potential donor and doesn't do anything. So hopefully these two decisions will be aligned with the outcome. You want to send as many solicit mails to those who you predict as high likelihood to donate, right? You want to ignore as many people who you don't believe they have a high likelihood of donations. Okay, so but sometimes you still make mistakes, right? You'll ignore those who actually is going to donate but you didn't recognize, and you're going to send some mails to those who actually not going to donate but end up to be a cost for the company. So here is the expected profit, is the gain minus cost of the decision and outcome. So under decision 1, if the outcome is 1, then you send a mail, you incur some cost of the postage, you get a big fat check. Let's say the check is expected to be $15, and minus the 50 cents is 14.5. So that's the expected return or profit of this decision under this condition. What's the other condition? You send a mail, but you didn't get a check. So that is going to be minus 0.5. Is you have some costs, and we actually going to revise it to 0 under decision 2, because under decision 2 the company is not losing anything and not gaining anything. So it's the non-action choice, right? So this is going to shift the weights of the algorithm so that it will prioritize, the accuracy of predicting donors and the accuracy of not predicting non-donors. But instead of simply being, treating them as the same, right? Giving them different weights, we'll treat them differently. So now we can do okay. Question?
Professor,
Kevin?
If there was that lost opportunity where the company didn't act, that person would have actually donated, would we have assigned that like negative 15, the company lost out on that potential, or we don't think of it that way? It's just 0 no matter what.
That makes sense.
Well, I don't know.
Yeah. So, the way you assign weights, it does have some requirements. It doesn't consider opportunity cost. So what we're just describe is opportunity cost. If you don't act on somebody who is going to donate, it's opportunity cost of okay. So from that window there, from those numbers to the actual reality, there is some little gap in conceptualization. The table actually does consider that situation is when you say, your return is 0 under decision true if the person is actually 1. But your return is 14.5 when your decision is 1 for those people. Right? So on the algorithm level, the algorithm will get feedback whenever it makes a mistake of tagging the donor to be non-donor. And in that case, the algorithm in the training process, it will recognize the opportunity cost and try to optimize that weights to minimize that mistake. So yeah, there is a distance there from the categorization to the actual process, but I assure you that is happening. Because the trick to specifying the weights is not thinking about opportunity cost, but thinking about real costs. Very good question. So we basically finished the first sample project, and in fact the decision criteria and weights and stuff like that, we are going to hit that maybe in week 8. That's quite advanced stage of making predictive models. First, we try to make a model that predicts with the lowest accuracy and treating different outcomes to be equally having the equal weights. And based on that, we will evaluate different models, but the evaluation is going to be contingent on the specific business cases. And that's when we introduce the decision weights and decision criteria. Any questions other than what we had? Good? So, I think let's, why don't we keep doing several mini tasks here. On chapter 4, we have a replacement task. Let's see. Oh, we do have to do these. Okay. Yes. Okay. So we need to create a diagram. Donation. And the first node is always going to be the data source. So what you do is simply to drag from the list of data source to the area. But keep in mind that this creates a copy of the data set. So then from this point on, whatever you do here is not going to be reflected on the node in diagram. So you would have to change over there. So this creates a copy. In chapter 4, we'll introduce some analytical tools. I'll quickly demo that. And the first thing is what you typically would do in any project is to use a tool to summarize the variables inside this sample. So under Explore, we have a Stats Explore that looks like a bunch of symbols. It will click and drag onto the diagram and make a link. Questions? No? A couple of things to change before we run it. And notice that there isn't a green marker there, right? We haven't run it yet. When you, after you highlight the node, after you highlight the Stat Explorer, its property panel will be activated. And we need to change, we want to know about the interval variables as well as the class variables. So we need to change this that's under train, big heading, and under the small heading is the chi-square statistics. Modify for the interval variable also to be yes. And in a minute you'll see the difference, or you'll see the effect. And that's the only thing we change. After that, you will right-click and run it. Or I guess the other way is to highlight that, whatever the node that you want to run, and click the shortcut. And running any node will activate the running process for any of the node preceding in the upper stream of the sequence. Right? So it will, SAS will check whether or not any of the upper stream nodes have run. If not, it will run it, and until it finishes the last node. Okay, click results. Oh, you get 3 windows. So the information here, this window tells you the overall relationship between each of the input to the target. So basically what it does, it ran a simple decision tree model in the back. So by doing this, you actually have run some decision tree models, but very simple ones. And the SAS process does it all for you in the back end, and it does it for every of the input variables here. So one at a time. So it has run a bunch of models in the back, and it ranks by a statistic here. This statistic basically quantifies the association, or the sort of the extent of informativeness of each of the input variable in helping you predict the donor. Does that make sense? So the variable worth of each of the input variable. You know, by simply using one of these variables, how much gain do you have in improving your predictions? So that's simply put, right? It's a direct comparison of the relative usefulness of the variables. Question?
Yes, Professor. Does each of those, that all adds up to 100%? That's what that's the takeaway. It is. If you added up all those bars, would it equal 100%? No.
It doesn't. No. It. Let's see. That's a good question, though. So the variable worth only considers a pair of variables. So similar to correlations, if you can imagine. Correlation is the amount of covariance between two variables. So right, so you can have a correlation matrix of many variables, but you can't simply add the correlation together. They would not make sense. So these are pairwise statistics, and those are not addable, if that makes sense. But this gives you a straightforward overview of what might be some of the variables that are likely to be informative and you want to include in the final model. So I want to take a guess of which variable might be the most informative about making predictions for a donor.
Socioeconomic sense.
That's a good one. Like education, those kind of information. What else?
If they have previously donated.
Yeah. That is actually a closer. So some of these variables might be very close in terms of the stuff that it measures to the target. The target is whether or not this person donated this time. But then, an intuitive predictor would be whether or not this person has donated ever. So So if a person has donated ever, it's much higher likelihood that this person is going to donate sometime, in the future. So it serves as a good, even sometimes better than socioeconomic status. The first one here is the frequency of the donations. So it is cumulative information about this person's habit of donation, if you will, something like that. So it does have information in there. And on this output window, it provides specific information about about an overview, or it's not individually, but an overview of the common statistics of these variables. One thing I would like you to notice is the number of missing values of each of the variables. It breaks it down to two types of variables. One is interval, the other is the nominal type, which is another name for a nominal variable is class variable. Categorical variable, class variable, or nominal. So all of these are nominal variables, including the target. It's binary, and there is no missing values here. So for the 20,000 record, 20,000 observations, we have full information in this, in these variables. But if you look at the interval variables, we have a longer list. There are several variables for which we have thousands of missing values. But one thing that we would definitely expect to have a large number of missing values is target D.
Yeah.
We won't observe for a large part because they didn't donate. Yeah, but target D is rejected, so we won't find it here. Okay, and it also shows some conditional correlations between the target and some of the input, depending on the case, depending on the outcome. So there are a wealth of information here. Okay. And the chi-square is quite similar to the variable worth. It's two different statistics that try to measure the same concept, but because the way of calculation, the formula is slightly different, so the ranking might be slightly different. But here, the number one variable that predicts the target is the same under two different metrics. It's the frequency status. So there are quite a large amount of similarities in the rankings. Okay, so this gives you a quick information about the big picture. Question?
I have a question.
Yeah.
Yeah. The worth on the side, it's units. Is it probability? What kind of units?
No, it's a worth statistic,
Uh-huh.
and so
Limited.
it's very small now, but it doesn't mean it's meaningless. It's very small. It could be because the distribution is quite, complex.
And what's the
Yeah.
maximum? Like
That's interesting.
4,000 out of what?
4,000,
Yeah,
like point, like
Yeah, like
3 decimal
points
point.
out of what?
Yeah.
Like,
Maximum, I say 1. Yeah. I'm not even exactly clear because it relates to the technical details of the models. Let's see. So yeah, that's basically what we do. For a tutorial, we're gonna create a partition of the entire sample. The point is to have a mechanism of cross-validation. Right? If you know the concept, if you know about overfitting, that's great. But we're going to learn it in a couple of weeks. That's a cricket. So we'll finish the partition and we'll take a short break. Under partition is under, it's not under Explore tab. We'll have to say sample, I think, under sample, data partition, you will drag behind that and connect that. There are some numbers to specify for this partition. So basically, we need to have a training set and a validation set. So we allocate, 40, 60, 60, 40, 50, 50. The exact choices of which is a little, sort of a, it's a judgment call a lot of times. For simplicity, we'll keep it 50-50 for now. And we'll keep 0 for test. So, yeah. So in the future, in model results and where we evaluate the models, we'll refer to train and validate. So when we say train, it's a training set. When we say validate, it's a validation set. We run it and we take a look at the overall statistics. So basic idea of, or to make sure that the partition does its job, we want to make sure that the two partitions are randomly made to the point that there's no mechanistic differences between the two partitions. We want them to look very similar on the overall distribution of the variables, to the point that each random partition can be seen as a typical random partition of the underlying sample. Does that make sense? And we want them to be similar because we'll have the algorithm learn from one partition and try to predict the other. So you would hope that the information contained in two partitions are similar. Otherwise, it's going to be problematic, right? So after the partition, it will give you a very brief report. It will give you the percentage of the different values of the target in the original sample. So for target B, we have two values. Possibilities, we have the percentage 75 versus 25, 75 being 0. And under the two partitions, we can see that the number of zeros are very close to 75%, if not exactly the same. It couldn't be exactly the same. But as long as they are very similar, they're almost unnoticeable, then it's good. It's good.
So if they're not similar, do we go back and change our...
You can change the random seed to try. So by default, SAS will use one random seed, which is 0, I guess. You can change it to a different random seed. It will generate different random samples, right? But if you keep doing random partition using the same seed, you will get the exact same samples. If you know the computing, background. It's rare case. The larger data set that you have, the more likely you'll get a similar partition. The smaller the data set you have, it's going to create unique data sets under some conditions. So you won't watch that if the data set is small. Right. Okay, let's take a break. We'll come back at 7:50. I'm pausing the video here. Okay, resuming the recording here. All right, so I'm gonna demonstrate one more task here, is to replace some of the values here. Just a heads up, there are several nodes that does things that are kind of similar and confusing. For instance, this one that I'm going to demo is replacement, and there's another node which is imputation, impute missing values, which is also replacing missing values. So both of them are replacing, but by different mechanisms. There's another node, which is in chapter 5 here, is transformation, which is also making some changes to the data set, but in a different means. So for the high level difference here, replacement is more of a hard coding, is you specifically replace a value of a variable with another specific value. So that's sort of a hard coding problem, right? You're changing manually, but instead of changing individually, you're using program to change it in bulk. But the mechanism is the same. Now, imputation of missing value is by using algorithms to figure out what might be the most likely value if the value was not missing. So that is using algorithmic mechanisms to replace. So you don't even know what the algorithm will replace in that specific case, but you have some confidence there because it is running a machine learning model in the back to try to figure out what might be the best way to replace the missing value. So that is more of a algorithmic based replacement rather than hard coding, right? And transformation is not exactly replacement, but sounds like so. Transformation is making a systematic change to the scales of a variable. So like taking the logarithm of a variable will modify the distribution of that variable, if you know a little bit about the background. Now, the tutorial explains something about logarithm transformation and what it does, but when I talk about the slides, I will show you what is it for and how do we do it. These are the technical means of doing that. All right, so we'll do a replacement here. Replacement is under modify. So do the drag. So here we're changing two specific levels of two nominal variables. So we're specifically targeting a level of a nominal variable and to replace it with something that is more appropriate. Under the train, you have the replacement editor. I believe that's a place. Yeah. Under class variable, not under interval variable. So it's here. Can you see it well on the screen? The fonts are good enough? Great. So under the class variable replacement editor, you will see a list of class variables, nominal variables. And the entire list of unique values under each of the nominal variable. So the cluster code has a lot of values. It's the geographic clusters code. So every cluster has a unique value here. So that's why there's many. We are going to change which variable? SES is the socioeconomic status. So there's a slight problem here. The data set is likely obtained from an old system, probably a system that doesn't have an internal means of representing missing values. So for any missing values, they will use a question mark. But question mark to SAS doesn't mean missing. It means a unique category. But we want it to denote as missing. So we will replace it with underscore missing underscore. That's the way we will code it. And same thing with urbanicity, has another question mark. We'll do the same. So after that, you can go ahead and OK. But don't forget to run. So now we'll finish our demonstration, basically. Take a look at the results. It reports what have been done and allow you to take a look at the data set. I think there's something I skipped, and why? Because I see all of the replacement variables made to almost the entire data set. But there's a way to fix it. Under interval, with the replacement, under train interval, something that I have forgot to do is to change it to none. So what it does, originally, what it does by default was the standard deviation from the mean, and the cutoff value by default is probably 3. So what it does is it looks for any extreme values that are lying 3 standard deviations away from the mean, and will replace them with missing. And this way, in some situations you prefer to do that because you don't want those extreme values to bias your model. But for demonstration purposes, we don't want to do it here because it's making too many changes. So changing that to no will nullify the action. So it will not do that. Okay, with that change to no, and with the replacement editor already changed, we'll run that again. Let's see. Did that happen again? So the replacement of the class variables that did take place from question mark to blank, which is missing. Let's see. Did this happen? So yeah, so I failed to change it before I run it. So I changed it back to explain it. So I have to do it again. So it's always a good idea to check after you have done something to make sure, it's a back and forth process, but making sure that you have done what you want to do. And I'm going to demonstrate another way to check the actions. So here, simply the 2 variables that are changed, and here this table shows you the number of values that are affected by the replacement. So only 231 observations gets changed under the training. Remember that we have 2 partitions right now. We have a train, we have validation. So the numbers are slightly different. Okay. Now, each of these nodes save a copy of the data set after it does something, right? And you have the option to get the data set out, to output the data set, to look at it if you want. do some diagnostic checks, and use others, use the SAS-based software to do any statistical analysis if you want. So what you can do is you highlight the node after you have run it, and you go to exported dataset, and click that. You'll get a list of possible data sets, but here there are only 2 because we didn't do the test. We didn't do the other tasks. We have train and validation, and for these you can browse it, or you can save it. Even you can do exploratory analysis, which I'll cover in the next 2 weeks. You can browse the training data set after the replacement, and you can see the changes. So the 2 new variables that are created after the replacement has the replacement information in the label, and a lot of it here is are missing. But that's true for the original variable. It does have thousands of missing values. And by default, you won't be able to find the original SES variable because it's automatically rejected from this point on. It doesn't make sense to keep both in it, because a large part of the information will be the same. So you want to only keep these 2, but not the original 2 variables. But even though it's rejected, it's in the back end. It's in the project file somewhere. You can still get them if you want. But for the process sake, for the further steps, after this step, you won't need to use the original 2 variables because the values are replaced. It's a better version of the variable, if you will. So this is another way to check that you have done what you expect to do, and by looking at the output to find sort of the indicators of the correct operations. All right, so I'll skip the chapter 5, and so you can do that as a take-home homework, but do let me know if you have questions. Right, so since the demonstration is over, I'm going to stop the recording.